Hi everybody, I hope you're doing well. This is going to be a short video that goes along with lesson number 1 in unit 10 on ingenuity. And this video is going to go through how to find the GCF of monomials as well as how to factor out a GCF from binomials and trinomials. The first two problems say find the GCF of the following set of monomials. A monomial means one term. So separated by commas, I have, for the first one, I have a pair of monomials. Monomials means that you're going to see no addition or subtraction. So I have two monomials for number 1, and I want to find the greatest common factor of each of them. So what we're going to do first is we're going to take a look at the coefficients of each monomial. So I have a coefficient of 4 in the first monomial and 24 in the second monomial. And I want you to find the greatest factor that goes into 4 and 24. If you need to use a calculator, do that. I do not need you to make a factor tree or find the prime factorization. They go through that a little bit on ingenuity. You don't need to do that. So if I take a look at the first number 4, I know 4 is a factor of it. 24 also has a factor of 4. If we divide 24 by 4, we get 6. So 4 is the GCF of the coefficients of the monomials. Next, I'm going to take a look at the different variables. So the next letter I see in the first monomial is an x. And if I look for that same letter in the second monomial, I have a different exponent, but it's x cubed. The GCF of the variables is going to be the variable with the lowest exponent. So technically, when we do not have an exponent written, we assume there to be a 1. And if we're comparing 1 and 3, 1 is the smaller number. So x to the first is going to be the GCF out of the x variables. And if I look at the monomials, I have one more letter. The first monomial has a y squared. The second monomial has a y to the 6th. I want to choose the exponent that is the smaller number. So y squared is smaller than y to the 6th. And I'm going to put these all together, the GCFs of the numbers, of the x's, of the y's. I'm going to put them together through multiplication. So 4 times x times y squared. This would be the GCF of the first pair of monomials. The next, I give you 3 monomials. So we're going to do the same thing again. First, we're going to take a look at the numbers, the coefficients out in front, and find the GCF of all 3 numbers. If you need to use a calculator, use a calculator. That probably will make things go a little bit faster. Like right off the bat, 12 I know is divisible by 4 and 3. I also know that 21 is divisible by 3. If I divide out a 3 from 12, I get 4. If I divide out a 3 from 21, I get 7. And if I divide out a 3 from 45, I'll get 15. And none of those quotients that are left have common factors. So I know that 3 is the greatest number that goes into all 3 of these numbers. So 3 is the greatest common factor between the coefficients. Next, I'm going to look at the letters. So the first monomial has an s squared. The second monomial has an s to the 5th. But the last monomial has no s. I'm going to signify that with a circle through a slash, with a slash through it. If that happens, if you get a letter that is not common to all of the monomials that you're looking at, it means that that letter does not appear in the GCF. So now I'm going to take a look at the next letters that I see. I see a t cubed. The next monomial has no t. So again, I'm going to use the null notation, a circle with a slash through it. And the last monomial has a t squared. I want to find the GCF. But again, because I have this null symbol, the middle term has no t's, t is not going to be a letter in the GCF. So if I look at the GCFs I came up with, I have nothing for the s's, nothing for the t's. The only part that I have a GCF for is the numbers. So 3 is the GCF of the second set of monomials. Next, we're going to take a look at binomials and trinomials. So binomials are expressions that have two terms. So for the rest of the examples on this sheet, we are going to see plus signs and minus signs. So what I'm going to take a look at now is 6x plus 15. And again, I'm going to kind of treat this like a problem up above. It's just that instead of commas separating the terms, now I have plus signs and minus signs. So I'm going to take a look at the first term and the second term. And I'm first going to find the GCF of the numbers. So I have 6 and 15. If I go through different factors, I know that they're both divisible by 3. If I divide 6 by 3, I get 2. If I divide 15 by 3, I get 5. And 2 and 5 don't have any common factors left. So 3 is going to be the GCF of 6 and 15. Next, I want to look at the letters. So the first term has an X. Does the second term have an X? It does not, so it's going to get the null symbol. And if I want to find the GCF between the letters, I have X and the null symbol. So because I have that null symbol, the X is not going to be a part of the GCF. So if I put the GCF together, I have 3 and the null symbol, so the GCF is just going to be 3. What we're going to do now, which is a little bit different than what we were doing up above, is I'm going to ask you to rewrite this by factoring out the GCF. So what that's going to look like is we're going to put the GCF after the equal sign. And after the 3, after the GCF, I'm going to put a set of parentheses. Now, to decide and determine what goes into the set of parentheses, we're going to divide every term in this expression by the GCF. So if I divide 6x by 3, 6 divided by 3 is going to give me a 2 with an x on the side. I'm going to put a plus symbol down because that's the symbol I have separating the two terms. And then I'm going to divide 15 by 3, which is going to get me 5. I'm going to do the same thing now. So this will be my final answer. I'm going to do the same thing now with the next one. So my first term, I see a coefficient of 4. The second term, I see a coefficient of 8. So I'm first going to work with the numbers and find the GCF. Between 4 and 8, I know 4 goes into 4, and 4 also goes into 8. So the GCF of the numbers is going to be 4. But now we have to work with the letters. So the first term, I see an x squared. The second term has an x. So the GCF between the x's, remember, is always going to be the exponent that is the smallest. So technically there's an exponent of 1 here. 1 is smaller than 2. So x to the first power would be the GCF of the x's. I'm going to put the two GCFs together with multiplication. What we're going to do next, though, is we're going to factor out this GCF. So I'm going to write the GCF, and I'm going to put a set of parentheses. And to determine what goes inside the set of parentheses, we're going to divide the original expression, everything in it, by the GCF. If I divide 4 by 4, I get 1. If I divide x squared by x, remember when we divide the same base, we subtract the exponents. That's back from our exponents chapter. So x squared divided by x to the first is going to be x to the first power. 2 minus 1 gives me a 1, which I technically don't have to write. I'm going to next put the minus symbol because that's the symbol I see next, separating the two terms. And now I'm going to divide 8 by 4, which will get me 2. If I divide x by x, remember I still subtract the exponents, but I'm technically subtracting 1 from 1. And 1 minus 1 is going to get me x to the 0 power. But remember, anything to the 0 power just simplifies to 1. So I'm just going to leave that as a 2, minus 2. Technically, it's minus 2 times 1, but if I multiply anything by 1, I get itself. So this will be our final answer here. We could always check our work by distributing the GCF back into the set of parentheses to check our work. The next one we're going to take a look at now is a trinomial. So it has 3 terms. So again, we're going to first take a look at the numbers out in front of all 3 terms. So 16, 16, and 48. And we have to find the GCF of all 3 of these numbers. Well, 16 and 16 are the same number, so the greatest common factor they share is 16. Is 48 divisible by 16? Well, if we're not sure, we should pull out a calculator and check, but it is. If we divide 48 by 16, we get 3. So between all the numbers, 16 is the greatest common factor. Next, I'm going to look at each term and look at the letters. So the first term has a y to the 4th. The second term has a y cubed. The last term has a y squared. So to get the GCF, I'm going to look at the exponents and pick the smallest one. To get the total GCF of the expression, we're going to put these 2 GCFs together through multiplication. So 16y squared. To factor the GCF out of this trinomial, I'm going to write the GCF. I'm going to put a larger set of parentheses just because we have 3 terms instead of 2. And we're going to divide the GCF into every term in the original expression. So I'm going to first start with the numbers. So 16 divided by 16 gives us 1. Remember, we're dividing the same base, so we should subtract the exponent. So y to the 4th divided by y squared, 4 minus 2 gives us a 2. Next thing I see is a plus sign. I'm going to copy that plus sign. Next, divide the numbers. 16 divided by 16, that's 1. Y cubed divided by y squared, we're going to subtract the exponent, so 3 minus 2 is going to be y to the 1st power. If you want to write the little 1 there for the exponent, you can. Next thing I see in the expression is a plus sign. 48 divided by 16, use a calculator if you need to, is going to be 3. Y squared divided by y squared, 2 minus 2 is 0, but remember, anything to the 0 power is 1. So this would technically be 3 times 1, which is just 3. So there's our final answer. We're going to go through just a couple more examples because I find that this can be a little bit tricky, and factoring is going to be super important. Finding the GCF is going to be super important for some of the other lessons that you're going to go through in this unit. So again, we're going to start these the same way. So All these on the next page are trinomials. So I'm first going to take a look at the GCF of the numbers associated with each term. So I have 60, 48, and 24. This one, the numbers are a little bit larger. So again, if you have a phone calculator, use it. If you have a scientific calculator at home, use it. You can use a calculator on all these ingenuity lessons and tests and things. So I noticed that 60 has a factor of 6. So does 48, so does 24. But is there a greater factor that is common between all of these? Remember, we're looking for the GCF, greatest common factor. So I noticed that 12 goes into all of these numbers. If you divide all of these by 6, the quotients that you're going to be left with are still all even. So a 2 could still go into them. So if you multiply the 6 that we took out, and then the factor that's still there, the 2, that's going to give us 12. That is the greatest common factor between all three of these numbers. Next, we're going to take a look at the letters. So the first term has an x squared. The second term has an x. The last term, though, has no x. So remember, I'm going to put the null symbol there. Whenever we get letters that have a null symbol, the GCFs, or the letters that we see, do not appear in one of the terms, it means that this letter is not going to appear in the GCF of the expression. So if I put these together, the null set kind of falls out. 12 is the only GCF of this expression. So I'm going to write the GCF, put a big set of parentheses, and to figure out what goes inside the parentheses, I'm going to divide 12 from every single term in the original expression. Get a calculator if you need one. 60 divided by 12, that's going to give me 5. But I still have an x squared on the side. I'm going to put a plus sign next. Then I'm going to divide 48 by 12. Get a calculator if you need one. That one's going to give us 4. But I still have an x on the side. Next, I see a plus sign, so I'm going to copy that. And 24 divided by 12 is going to give me a 2. So there's our final answer for number 6. Number 7, again, I'm going to take a look at each term, and I'm going to look solely at the numbers that are in front. So I see 24, 20, and 16, and I'm going to think about, what do I know goes into all of these numbers? I know they're even, so a 2. I know a 4, maybe an 8, but 20 is not evenly divisible by 8. 20 is not divisible by 6. So 4 is the greatest common factor between 24, 20, and 6. I'm going to then look at the letters in each term. So I'm going to start with the m's. So the first term has an m squared. The second term has an m cubed. And the last term has an m to the 4th power. To get the GCF, I look at the exponents and choose the smallest one. But I have another set of letters I need to take a look at. So the first term has an n to the 4th. So now I'm going to take a look at the n's. The next term has an n, technically to the 1st power. And the last term has an n cubed. If I look at the smallest exponent, it came from the n to the 1st power. And to get the complete GCF, we're going to take these 3 terms and multiply them together. I want to factor out this GCF from the original expression. So in order to do that, I'm going to divide the GCF from all 3 terms in the trinomial. I'm going to start with the numbers. 24 divided by 4 is 6. m squared divided by m squared. Remember, 2 minus 2 is 0. That's going to just simplify to 1. N to the fourth divided by n to the first. 4 minus 1 is 3. I'm going to copy the minus sign that I see next and then start the process again, starting with the numbers. So 20 divided by 4 is 5. M cubed divided by n squared, 3 minus 2 is m to the first power. N divided by n, technically 1 minus 1 gets us 0, and anything to the 0 power will be 1, so that will fall out. And then lastly, I'm going to put the plus sign and do the process one more time, which is going to give me 16 divided by 4 is 4. M to the fourth divided by m squared, 4 minus 2 is 2. N cubed divided by n, or 3 minus 1, will give me n squared. We have one more example. And again, we're going to start it the same way by looking at the numbers and deciding what is the greatest common factor between 16, 24, and 32. Well, I know they're all even. I know that 4 goes into all of them. 6 does not go into all of them. 8 goes into 16, it goes into 24, and it goes into 32. 8 will be the greatest common factor. Next, I'm going to look at the letters. So the first term has a b to the fourth, so I want to do the b's next. Next term has a b squared. And the last term has a b to the fourth power. Find the b with the smallest exponent. That's going to be b squared. I also, though, have the letter c. The first term has no c, so I'm going to put the null set. The second term has a c cubed, and the last term has a c to the first power. But remember, when you see the null set or a term that does not contain that letter is not going to appear in the GCF. So if I put together what I have, it's just 8 times b squared. The last step is to factor out the GCF, or divide the GCF from every term in the original expression. So we start with the numbers. 16 divided by 8 is 2. Next, we move on to the letters. B to the fourth divided by b squared is b squared. 4 minus 2 is 2. Next, we have a minus sign. 24 divided by 8 is 3. B squared divided by b squared, or 2 minus 2, is 0, which will give me 1, so technically that falls out. But I still have a c cubed. I can't forget about writing that. Next, I have a plus sign. 32 divided by 8 is 4. B to the fourth divided by b squared will be b squared. 4 minus 2 is 2. But I can't forget about the c on the side. So I hope that these couple of examples helped you better understand how to find the GCF of monomials and factor the GCF from binomials and trinomials.